How's it, Jordan here? In this video, I'm going to be showcasing my very badly implemented neural network with really not really working training.
So what do you mean by that? Is it a disaster? Hi there.
So, yes, I got my dad here again.
Just some moral support because he's been crying for the last 4 days.
Right. Yeah, I don't know about that, but so I got a neural network working, and before
Before that, what was the reasoning around? You got that other neural network working. It was nice and visual. It was quite cool that you could actually see something. Now it looks like there's no visual. It's not very exciting. But what you wanted to do something more like in Swift, right?
Yes, so my goal was to make like a easy TensorFlow kind of style thing in Swift, since I can't find any out there really, and also just for funsies, be quite interesting.
So what was your initial idea around this? Why Swift? Why did you even attempt it?
So since my last video, I kind of got bored of neural networking and did games again, but then I wanted to try out CNNs, convolutional neural networks with image recognition.
Come on, don't lie. You were like so excited. I've never seen someone so excited. You were like going, oh my God, this is so freaking exciting. I mean, I thought, wow, what's happened? What's going on? And I asked you, why? What is exciting? Convolutional, blah, blah, blah. And I went, what? And I've never seen someone so excited. I mean, this is what it is to be a developer. You need to be excited like this. If someone out there that is excited to code, that's what it is. Now, my wife is also a developer, and I used to be a developer. We were never excited like this. Never. So, I think that if someone is excited about developing something from scratch and is like, "Well, I'm so excited," then you know that that's someone that should just be coding and doing this type of stuff. Don't force him to do something else. Just let him code. Anyway, carry on.
Yes, so I actually
You were excited, eh? I mean, come on, let's be honest.
Yeah, I'm super excited at this point, in fact, to carry on with different things. I'm going to make a version of TensorFlow. It's open source. See if I can make a Swift TensorFlow, since there seems to be Java and C.
Okay, let's not jump the gun here.
Yes.
You were crying about this because you couldn't get it to work properly. Explain the reason why you went the Swift route. Explain what went wrong with this particular project. Why you couldn't get it working. So let's move from that point.
Yes. So I got the CNN first part working, but then
what is the CNN? Explain
so
that.
it's for image recognition. So I'm trying to I'm following not tutorial, but a kind of visual guide on how neural networking works, and includes a part on CNNs, and it's going to determine whether it's an X or an O out of pixel art drawing, right? I actually got that working.
Explain that. What does that mean?
Well, let's say you draw a doodle, let's say. I think I think it's Sebastian League did a doodle where you draw a doodle and determines what it is, what kind of thing you drew. I'm going to do the same kind of thing, but in this case it's for start only X and O. And I got that working, but I needed the neural network part of it. And this is why I'm doing this part.
So how did you get that to work? And explain to us.
Well, I did, so you have to put it through special filters, basically. So all it does is it scales down the image to a tiny, usually like 2x2 or 3x3 pixel image.
Okay, why does it do that? Why do you need to do that? Is it just easier to work with?
So it does that, and it puts it through a special filter to determine. So what it does is it determines, let's say you have a line, which is the main part of an X. It makes a map of where the lines are, and you can have let's say different lines in different directions. It will determine what part the X is. So just get a rough idea of where the X is, what it looks like.
It's almost like we should draw it out, but you can't. At least you can explain it. So explain it in the code, I think.
Well, I can actually show you since I can open it quick. So
okay,
I just
cool.
do
Go
that.
for it. Yeah. Okay, so is that what you did? Oh, I see. Okay, so you did little like matrices there.
Yes, tons of matrices. So if we have our image map, so it might be a little hard to see, but if you can see it properly, I don't know if YouTube compression will like this or not, but it has -1s and 1s. This can be any number between -1 and 1 though. And 1 is on and -1 is off. and I just have a little a pixel art drawing of an X, as you can see here. There's the same here. It just has 2 forward slashes almost.
Oh, wow. Okay, yeah, that's cool. Yeah.
Now, this part I hard-coded, but this will be part of neural network as well. We're determining what really defines an X. So we have a backslash, and we have a forward slash,
Nice.
and we have the middle part, which
See how
is
important it
just
is
where
to
it connects.
visually articulate it from.
Yeah, this way-
It's so funny to actually say you're visually articulating it from ones and zeros and lines. I mean, that's quite fun. Anyway, carry on. Sorry.
Yeah, but I'm just doing a comparing. Then I have a thing called a deep stack, and what I do is, for now I've only done one. Of course, for this you'd have to compare it with backslash, cross, and forward slash. For this, I've only done a thing called deep value, and it's a deep stack, and I give it the original image
What is a
map.
thing? What do you mean by thing?
Sorry. We have our image map, and all I do is I compare the image map, a certain 3x3 grid of the image map, to the 3x3 grid of a backslash compare, and slowly do that again and again, iterating through every part of it.
Oh, that's really interesting. Okay, and you
And-
came up with this idea
Well, I
yourself?
didn't come
or
on.
did-
No, absolutely
way.
not. No. I watched a great video explaining how a convolutional neural network and just different, and even generative AI at some point, how it works. But if we can actually run it, it does work.
So why were you crying? I'm just joking, bro. Why were you a little unhappy? You've been working on this for at least four days solidly.
5 days, 6 days, I'm not sure, but quite a while. And because I just couldn't get training working. I have no idea why it doesn't work.
So it's up on Git at the moment.
And
what's
it's-
nice about you? You're 12 now. Maybe when you're 13 or 14 or 15, you can go back and go, oh my God, I just did this. That was so dumb. This is why it didn't work. Or, wow, how the hell did I manage to do this? It's like, it's a total mess.
But I really, really hope it's not saying like X is equal to a wrong value, like 0.1 off or something. That'd be really irritating, because that always happens to me. It's always like a single variable always that breaks the whole thing.
Yeah.
But you can actually, the source, code is all open source on GitLab right now. Well, whenever you want to check it out, it's in the description. But anyway, as you see here, it checks for a backslash or a diagonal lines, right?
Yeah.
In this direction. And as you see here, it sees an X, it sees a diagonal line in it.
Okay,
Because
yes.
there is a
Yeah, I see
diagonal
that.
line going all the way through here.
Cool.
If we check for a cross, so it obviously this doesn't have a center. So it just says 1 over here in a kind of weird corner. But it does actually see, because the center point, it has an exact map. And everything else, it doesn't really think it's very high in the values.
So explain to us how you came up with the probability or that percentage, 0.33 and 0.55. Where did you define that?
So the deep stack, I'll just explain deep stack a bit more, because it helps explain.
So let's carry on now. Okay, I see this looks a little complex. Can you explain it?
So we have if we just go up here, as you see in our deep stack, we go through a list of commands we're checking, we're filtering the image slowly through.
Yeah.
So the first is we have filter the image. If we go this function, we have a compare, and this is the compare part. It's comparing a certain aspect of this. In this case, it's just a very primitive parts like a diagonal lines or the middle part of an X, where all the diagonal lines connect up. And if we just go our filter, my lovely messy code, filter image, we have a compare and we have the image, which is our main image. So we're just looping through the entire image, and every point we have a result of filtering that we're adding, and we have a filter. So the filter image inputs the image map, which is our main image, and the compare map, which is a compare, and an X and Y parse, which is where it's checking on the image. Then it gives a 3x3 grid, and it doesn't matter if it's out of bounds. It checks that, and it just skips that part. Then I have a result. I plus it, and this is the result we're returning. We plus it by map value times by the compare map in that X and Y paths we're looping through. So we're looping through a little 3x3 grid, and the X and Y path is the center point of that 3x3 grid on the image. We're just comparing them, and then we're returning the result divided by double dot count, which is getting the average, I guess. Yeah, that's average.
Yeah, that looks pretty understandable, to be honest.
And if we look here, it gives out higher values where it's most primitive, that point.
Yeah. So, I mean, I see you've done this in Swift. You love Swift.
Oh, I love it. It's like, apart from C#, it's my main language. It is my main language, really. C#
you only started Swift work a few months ago. You just absolutely in love with it now, right?
Yeah, I love it. It's my favorite language.
Why do you love it?
It's modern syntax. I don't like C++, let's say, because of its weird, just old-fashioned looking syntax, like push and pull and all those weird array things, and the ugly syntax. I just love Swift. It has beautiful syntax, similar to C# enough that I can understand it very easily, even if I'm a beginner.
Yeah.
It's just, I just love everything about it.
And of course, the IDE, as we pushed previously, the IDE is fantastic.
Yes,
also.
It is like my favorite IDE. It's so nice.
Xcode.
Yeah, Xcode.
Totally free. Woohoo!
Even lets you use, I know, it's better than things like IntelliJ or something where you have to pay tons.
Shh.
Yes. Not get revoked from any weird IntelliJ things.
Yeah, anyway. Yeah, Apple's just done an amazing job on that. Kudos to them. Anyway, that's great. I don't want to break your train of thought here. So that looks awesome.
But I'll just show you here, we're comparing the cross compare, which is the little cross part in the center point. Or here it's just kind of randomish values, but here in the middle it's 1. Now this is really amazing. This shows it's working well, because it says that the middle part which is the center point where it is a cross. It is a cross.
It's indexing. It's intersecting.
Yes, it's all intersecting.
Yeah, that's awesome. Okay.
Now all these parts are hard coded, but this
I'm using big words there for you, huh?
Yes, intersecting. Yes. And all these have to be determined by neural network as well, but I didn't get around to that yet.
Oh, what a shame.
I am going to, though, once I get a neural network working.
5 years later.
Yeah, exactly. Then I have a thing called ReLU, and if you watched my neural networking courses, you'll know, my basic neural networking courses, you'll know ReLU is just a activation function that makes sure it just clamps it. It's just a clamp to make sure it can't go below negatives. So now if we run it, you'll see. That's weird. Oh yes, of course. Sorry. The reason why is because I was printing out filter. Now I can print out the ReLU.
Yes.
Whatever, it doesn't matter. And as you see, all the negatives are now 0. And that works. Then we put it through another pooling.
Pooling? What do you mean pooling?
Okay, so I didn't explain pooling.
Your accent is very strange.
My bad pronunciation of pooling.
Well, it's South African, Anglo, African, pure African, Anglo.
Yeah. Anyway, so it's very similar to a filter. It puts it through a pool, and it's the same thing. It inputs an image, but no compare image. And what pooling does is it makes the whole array smaller. It squashes it. And now normal squashing would do some weird blurring.
I love that normal squashing. That's fantastic.
Would do some weird blurring effect or just make it weird output that you can't work with. This though, it does. It just squashes it from a 2x2 grid, I believe. Yes, 2x2 grid. Or is that 3x3 grid? It's smaller than 2. Yes, a 3x3 grid. And it checks if it exists. And then what it does, it has a result at the top variable, right? Outside the X and Y loops. And if the image at that position it's checking is more than the result, then it sets it. So it only gets the highest value. So let's say it checks right here, let's say this little 3x3 grid. The highest value in this point is 0.55. So it sets it to 0.55. And I'll show you what that looks like. So if we let it pool, as you see, it gets like really small. And 0.55, there we go. You can see it work really well. And just squash it down, but retains all the detail that's necessary. So it doesn't lose any important data. Then we put it through another ReLU, and then we put it through a pooling again, and it gets even smaller. So in this case, I think it would be 1. And 1 in the corner. That's why 1's in the corner at the end. And I just put it through a whole stack of these. And what I can actually do, so let's say I just go this, and I haven't really done the rest part because I need a neural network to do the rest, to do proper image recognition, but I do 1, 2, 2.
The whole reason why you were so unhappy with this is the training part, right?
Oh yes, trainings, it does actually work, but it's quite hard to test.
Can you show, once you finish with this, can you show someone how you tried to train it? What was your idea around the training?
Yeah, I like to say it's a really half-assed solution of training, but it
was your first attempt. I mean, you're like 4 months old in neural networks. 3 months less. So, I mean...
Yeah. I'm not an expert, sadly, yet. But before we go to the project again, as you see, the \, it does its correct orientation. It does the diagonal. Then we have the cross compare, which tries to do it in the center. And then finally we have the / compare, which does it, it doesn't seem to be able to do it properly, but it does try. It does 1 and 0.77, which is good enough. I mean, it preferably would be 1 and then 1 here, but for some reason it just doesn't do it.
Yeah.
Maybe it's good.
It's your first try. I mean, I'm impressed. Okay, cool. Are you going to discuss now or explain a little bit about the training, or what's the next step?
Okay, we can explain the training. So the first part is the high level stuff. This is stuff if it worked, you would code. So we initialize a few layers. Now you don't have to initialize thousands of connectors. You just have each layer is connected to each other layer. So we have a layer 1, the input layer, which has 2 neurons. It's connected to layer 2, which has 2 neurons. We have to give it a previous layer. And then we have layer 3, which has 1 output neuron, and it has a previous layer of layer 2.
Otherwise it'd be very lonely. So it's not a lonely thing here.
Yes. It all has friends, layer 2 and layer 1. Then we initialize net, which is our neural network. We give it all the layers and we give it a learning rate. And we have some inputs. So the inputs in this case is what you give the layer 1. And we say 1 and 0.5. And then the target output for this is negative 0.5. So this is for training. Then if we go net.train, input values...
So it's very hard-coded at the moment, obviously.
Well, this is sort of what you would be doing, actually, preferably. But usually you'd probably give it some data set. I've been playing around with Python in, TensorFlow. And just to figure out how exactly it does work, proper neural network. And you give it some .csv file for it to learn from data set.
Or a database or a data set or some
kind of... CSV, literally you give it a CSV file for the data set. Yeah. Then we train it, and then we calculate the neural network in the end, which is, let's say you input some values, it's what you should get out of that. So then I just print connector weights. So if we just, I'll just add a \n new line just to make it a bit easier to read.
Yeah.
And I'm just going to add
And you hope now. You hope.
Yes, I hope. And then if we have test inputs, it should give a value close enough to negative 0.5.
And it's so freaking fast there.
Oh, yeah.
I mean, Swift is so awesomely speedy compared to Python.
If this is slow, then I'm worried, actually.
Yeah. But you've been playing around with Python too, and you found it a little pup?
Yeah, I don't like Python. I just don't like its syntax. I don't like much about it.
You're stuck there because everyone's using Python, so...
I know, so I have to use Python for TensorFlow.
You will conform.
Yeah, I have to use it in Python. Oh, well, but I just printed out the errors as
Make it a bit bigger so you can see that it's going on here.
So as you see here, it's slowly, this is why it's trying to train it. It is actually, the error rate is going down and down and down, so it is actually training it. And then we have the output, which is negative 0.39.
0.39. You should kind of tie
And-
that off a bit, round it off a
Yeah,
bit.
but I want exact. And then our target is negative 0.5.
Okay, so
And so negative 0.39, it is quite
It's actually
close.
quite
It's an
good.
error of 0.1.
okay, isn't that what you really wanted initially?
Yes, but the problem is you can't train it on. It just doesn't work very well. You can't train on multiple things. It's just really broken.
So this was just a proof of concept for you, just to see how the hell you can do it yourself, just from a starter, novice point of view.
And I guess if you wanted, you could just download this, remove the training, replace it with proper training. I guess if you really wanted to, and the neural network is fine. It works brilliantly.
Okay.
Yeah, very similar code to how I did in C#. It's pretty much a copy paste and refactoring a few things.
Do you think it improved? How did you find C# plus Swift?
Well,
Is it easier
to be fair, they're very similar. Some syntax are like Ben Swift, some syntax are like Ben C#.
speedy, the way you...
Like I wish I had namespaces. God, it's so irritating. I really miss namespaces because Swift can't support proper namespaces. You have to use some structs, which I can't really do.
Okay.
But yeah, it does improve it from error rate of 0.7 to 0.1. And here all the weights are outputted in order of all the layers. I'm not that happy with the project since the training did not work as intended, but I still think it was an interesting project, so I hope you enjoyed this video, and I'll see you next one. Bye!